Okay, thank you. So let's start. Maybe just a quick check in case that some people cannot hear us, or if people can hear us, please just again, just give us a ping because we had some audio issues just before this webinar. Okay, so let me start. My name is Veselin Pizurica and I am a CTO and co-founder. And let me start first with just a small introduction about the company. We are a Belgian company that exists for about 5 years. Our focus is primarily on automation and time series analytics in context of the IoT. And today we have about 40 enterprise customers from Australia, Europe to US, and a variety of different verticals from smart buildings, HVACs, to utilities, home automation, smart cities, and so forth. And at the very beginning, I would just like to say that this is, in a way, a second part of the webinar that we had about 1 month ago, which was really focused on the automation specifically. And for people who have missed that one, please let me just do a very short recap, just as a precondition for continuing this conversation with doing much more in-depth analysis of the automation technologies. So what we have mentioned last time is that in context of the automation, there are 2 different technical, let's say, challenges that you have to address when you're doing the automation. The very first one is related to the IoT architecture. And what we meant by that is that typically, as you evolve your IoT architecture, you look at, if you like, linearly from connecting and collecting data to dashboards and analytics. And then at one moment you would like to add automation to that, you realize there is a particular problem with that. What I see here on this screen is that I often sort of kind of try to explain analytics as sort of a net fishing problem, where you are searching for a fish of a particular size or a color. While if you look at automation, this is pretty much like a pole fishing. You are interested in a particular instance, you're interested in a truck that ends up in a warehouse. You're looking at a connected building, you're looking for the HVACs on a given floor, or even more so if you look at utilities, oil and gas, or assisted living, you always look at one particular entity at a time, which is connected to one user, which needs to get an email or SMS in case of the excessive usage of water or a leakage and that sort of thing. So here we are not arguing that analytics is not needed. In context, it's a very important aspect of the IoT. But again, going from the analytics into the automation, what people often forget is that automation is a startup topology. What we mean by that is the automation requires constant connections to stream data, IoT data if you like, time series historical data, anomaly detection and prediction models, meta models as well, which is also very important. What I mean by that is that, for instance, if you want to switch off lights or the HVAC on a given floor, you need to know these relations as well. Similarly, you have to connect with ERP systems, backend IT systems. You need to have access to notification systems, machine learning, and API models, and in general, all API external services that you may want to use for the automation. The second part of the challenge is, if you like, also in a way technical. It's that there is a desire to express complex different use cases through the rules engine because that enables building application at scale. But there is also the second part of that, which is to do with the operational scaling aspect of the rules engines. And today, if you like, my webinar will be really mostly focused on the automation and trying to go through different use cases, different verticals, and see more in specific what we mean by this second challenge. So before I start with benchmarking and talking about rules engines, for me it's extremely important to kind of start comparing apples to apples. What I mean by that is that if you like comparing middlewares, and here you can take example of the databases, you know how to compare them because you have agreed upfront what are the benchmarks and metrics against which you're going to compare these things. Similarly, if we talk about comparing apples to apples in context of the rules engines, the first thing we have to agree upon is what are the metrics against which we're going to be scoring our rules engines, if you like. And what we have come up with ourselves, which is much more elaborately described in the white papers. It's a benchmark criteria which talks about, if you like, this matrix. And if you like, there are two different categories of the benchmark criteria. One are related to simple, if you like, technology criteria in context of the rules engine. Is my rules engine good enough to express all modeling that I'm required to do? While not to forget, there is even, if you like, a more important aspect of the automation, which is moving from, if you like, academia to reality, to the enterprise things, which is how easy it is to deploy now this automation for my particular use case. And then we talk about other aspects of the benchmark criteria, such as explainability, adaptability, operability, and scalability. So this is where we have ended up, if you like, the previous webinar. And so what I would like to actually do today is to go deeper into each of these metrics and then show in real life what we mean by each of these benchmarks. So if you look at the modeling of the complex logic, what we actually would like to mention here is that you as a developer, you as an automation engineer should be able to combine multiple non-binary outcomes or functions in your role beyond simple true-false statements. What we're saying typically is that automation, if you think about it, it's about combining multiple outcomes. For instance, I'm interested in it's weather nice and I would like to go somewhere if it's in the weekend, and then I need to buy a ticket and other things. So you see that there are actually a multiple of outcomes which are required to do something. Similarly, you would like to deal with the majority voting sometimes, meaning that you are interested in 2 out of 3 outcomes to be successful before you do some other things and so forth. Now, in order to basically explain that more tangibly, so I will just give you one very simple use case from the home automation, which tries to check 2-3 different metrics. And for instance, the room temperature, whether it's within the range, like 18 to 26 degrees, whether the humidity is within the range, and whether the CO2 levels are okay. And if there's something wrong with some of these measurements, I would like to check the weather outside. Maybe someone forgot to close the window or that sort of thing. You can think of that in context of home automation or in data centers and so forth. So what I see here is that if you would like to combine these things, it's that you have in range, below, and above states, and you have 3 different outcomes. You end up with some sort of a matrix which is 3 times 3 times 3, which is like 3 nodes with 3 states, which is already 27. And then you still have to do something to decide whether you should do something or not, which is multiplied by 2. So you already end up with 54 different outcomes with only 3 sensors. To show that in reality, so let me just show you quickly that I'll be looking at one particular room. So just that we see that something like happening. And what I'm gonna show here is that I will just look at this rule here in particular and check whether the humidity is above the range. And you see here popping up here, we are still not sure whether we should raise the alarm or not, or whether we should check the weather outside. And I will just make now temperature to also be above the threshold. And you see now that we are checking the weather, which is right now in London raining. So you see already, if you look at very simple chaining of the states between different sensors, that how easy this can get very complicated if you have to write this stuff in the code, or if you would like to just use some rather simple rules engine to express these difficulties. Now this might be looking as a kind of a forced example, but let me just show you one from the e-health, a real one, so to speak, where you have, for instance, the check for the septic shock, which includes check for the heart rate, temperature, then some respiratory rate measurements, the drops and so forth. You see how easy these things can get very complicated, and how important it is to be able to express the multiple outcomes in the rule and being able to debug the statements while you're making the rule. The next aspect of the rules engine its capability to deal with the time. So what we mean by that are the three different categories within that. One is to be able to deal with the past, meaning that every piece of information, if you like, should expire at one moment in time. So if someone opens or closes the door, it's happened within 5 minutes or within a second or 10 seconds and so forth, and you should be able to express that within the rule itself. Second thing is that you should also be able to deal with the present. Now we'll see that in a moment that often the IoT data comes as asynchronous data streams. It comes from the sensors, it comes from the HX and so forth, while the synchronous streams are something that happens through the API. So if I'm going to fetch the weather forecast, I'm going to hit a specific endpoint and come back with the data. If I see something that comes from the HX as error code, at that time I need to check through the API database system, which gives me a particular problem related to this error code and so forth. So we really have to have, specifically in IoT context, possibility in the rules engine itself to combine what we call synchronism and synchronism. And finally, we should also be able, for the rules engine, have in our hands capability to use the prediction and anomaly models. And let me just now go back into a particular example, so I think it's going to be much easier to explain that. So again, I will just get into a particular template. So let me go for the motion sensors. So what we're going to do here is that we'll have two motion sensors, and I will evict each of these every 5 seconds. And what does it mean? It's that for the alarm here to trigger when the motion is on for both of these motion sensors, this data must arrive within 5 seconds of each other. So let me just show that here in a very simple way. I'm going to test that, and I'm going to make a node 1 to be in a motion. And what you see here is that we have the very first one in a motion, and then within 5 seconds, it's just going to go back to priors, meaning that it's either on and off, we don't know anymore. So with this way, we can basically, on a sensor level, describe how long we trust information itself. So for instance, now if we would like to have a rule which triggers while both sensors are on, that means that the data must arrive for both of these sensors within 5 seconds. So this is one example where, if you like, you would like to have what we call eviction policies. Similarly, if you think about combining rules which have, let's say, the motion sensors or any information with the weather forecast information, you should be aware that, for instance, API call might break, might give you return error code. So somehow you need to tell a rules engine, yes, I trust this weather forecast for the next 1 hour. If the API is not responding anymore, I should be able to disregard this information. The next thing that you also would like to do, and I'll just quickly explain it as well, is that you should also be able to model what, let's say, CP engines are very good at, which is being able to model state transitions or aggregates or averages or minor marks or first derivatives over time. So again, I will just show you here what we have. We have a small function node that is searching for the events that come in a sequence of on, off, and on. And what I'm going to do here is that I'm just going to start that task just in a debug mode and see how my rule will then react on that. So I will just start saying that I have a switch always on, and if in particular sequence I put it on, off, and on, I should actually detect that sequence. And moreover, well, I can actually add some more things, like it has to be twice off, it doesn't matter. Let's do that like this, and here we go again. Now, if I would like to try it again, have on, and then off, 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 on, then again I should detect that sequence. So this is again one of things that you should try to find in rules engines, capability to express the rule through the historic information about the state transitions, or being able to deal with the time, the sensors which are somehow tied to a particular time interval which you need to track this information. The next thing that I mentioned earlier on is capability to somehow mix and match the data that arrives through the streams together with API that comes from the backends that give information about the weather forecast. So let's quickly do that. So what they're going to do now is they're going to not use the model from template. I will just here say I'm interested in a temperature and threshold, let's say 21 for the stream data, and I will also take then the current weather, for instance, for city of Ghent, where we are located. And again, I will use the same idea of eviction every, let's say, 10 minutes, while I'll be polling data every 5 minutes. And what I'm going to do now is just say that, let me actually test what's the weather in Ghent, even though I can see it actually outside, it's raining. And I will say now that if the temperature is above and it's raining, I would like to actually do something. So let me do it quickly here. And then I will basically put here a debug window, which types some sort of a condition saying here, let me just put it like this, hello. And then let me put here the values of the temperature and the temperature that comes from the API. So here we go again. I have my rule that mix data that comes from the stream data together an API. We see already that we have got an API call and it's indeed raining. And if I now push data of a temperature and let me now bring that above the threshold, we see that now we have a room temperature for like a stream data, which is 23 degrees, while the temperature outside again is around 14 degrees. So again, these are the things that you would like to have when you're modeling the automation in the context of the IoT. This is something that is, I believe, very specific to the IoT use cases, capability to match the stream data together with the APIs at the moment you're building the rules. Then let me go then to the next part of the, if you like, the time information which you would like to have in your rules engine as expression capabilities. We hear more and more today people talking about anomaly detection and prediction, as this is some sort of capability which comes out of the blue as a microservice, and this is all you need to be able to build the IoT use case. And similar to my point on the analytics, it's all great, but how you actually embed that into automation to be all other building blocks that you have already. So what you're going to see here is that I have some data that has been stored in my system. And here I will be looking at, for instance, something that we have in a DevOps. We are monitoring some webhooks from some external systems. And what I'm interested in now doing is that actually look at the place where there is no issue. And then I build my models. And later on, I'm going to scan through all my collections and then try to decide at which moment I am interested in seeing the anomalies that I would then like to declare and use in my automation. So here again, I'm just showing you some pieces of prediction anomaly detection algorithms, but again, this is just one of the building blocks that you would like to use in the rule. So how you do that, let me just show you here. I can actually build some sort of the models for different time intervals. What I mean by that is that I might be interested in errors that are happening on the level of the 10 seconds or 50 seconds or a minute. Or maybe I would like to zoom out and look at the data and search for patterns which are happening over the days, over the weeks, and so forth, and then use such models to express my rules. So for instance, here, I'm interested to see whether there is an issue while we are knowing that there is a daily pattern which our system or the metric which we are monitoring needs to adhere to. So for instance, here we have a significant drop at one moment and would like to declare that as an anomaly. Now, what you would actually like to do now is to go back to a rules designer and use this information like any other that you had before. So for instance, you had a stream data with the thresholds, or if you had the weather forecast in your system, any other thing, you can just simply start wiring the things here and you don't care anymore whether the data comes from the prediction models, whether it comes from the APIs or the stream data. Let me just show you here quickly. This is a real system that our DevOps is using, and if you look at here, they're looking for exactly the same metric for the webhooks, and basically the guy has created a, so let me just go here because it's a live system. I really need to go this way. So you see here that there is no particular anomaly. If there is anomaly, the person will get a Slack message. Again, this is just one of the examples how you can use the anomaly detection as the microservices to like exposing the rules engine. Similar for the prediction models, you can do the same thing. You can use something like a time to target, saying that if the battery is going to be flat within 2 weeks, then send me an alarm. Or if the energy consumption is going to be above 10 kilowatts in the next 3 months or a month or so, then send me email and so forth. So these are all building blocks that you would like to have in your rules engine at the moment you are building the automation scenarios. Then the next thing that again it's something interesting to have, and again depending on the vertical you might be interested in this capability as well. It's a possibility to model the utility functions on the or to use the rules engine as a kind of probabilistic reasoning engine. What I mean by that is that, for instance, just give you an example of the elderly care use case that actually we've done some time back. Is that, for instance, your rule says if the fridge is not open before 10 a.m. and the medication is not taken because you put a sensor, for instance, in the cabinet in the bathroom, and then you have some other motion sensor connected to the door, and if nothing happens before 10 a.m., then you really should worry. And if, for instance, 2 out of 3 things have not happened yet, then you may be worried a little bit less. And depending on these outcomes, you might want to call hospitals, or you call their children, and so forth. So these are the places where I will not go too much in detail, but again, you can actually see it here, is depending on the observations, you're more or less sure about things that needs to happen. And like in this case, when the fridge is open, or closed, sorry, while still other things have not taken place, you might just want to raise an alarm to your children, while after 10 o'clock, nothing has moved, and medication is not taken, maybe you have to raise alarms and inform someone else. These will, if you like, with this I would close the very first 3 categories of the benchmarks, which are related really to the technicality, if you like, of having the rules engine as a tool, as a means of expressing the automation use cases. While the next 4 will be really more focused on the how to basically bring that game into the enterprise context. And let's start with explainability. What we mean by that is that the intent of the rule should be easy and understandable by all users, developers and business owners. The second thing, which is also important, that the representation of the logic should be compact, because it really enables much better building the applications on top of that, and also debugging, which is a separate topic, if you like. That simulation debugging is extremely important, and I would like here to distinguish between really simulation debugging and exploration, because exploration is also something that enables you to get the data logs and run them against the rules before you deploy them in real time. One thing that I would just like to show you here, why the explainability is so interesting, is that then you can really easily build applications in a matter of hours, if you like, providing you have the right constructions to build the rules in a very easy way. So I'm going to show you here, it's something rather simple. You have an HVAC and you would like to see that if an HVAC goes above, let's say, 10,000 compressor hours, and let's say whether there is a weekend or not, should I alert someone or not, I should send the guy an email saying, look, you should check this HVAC because, you know, there is a maintenance that needs to happen with this HVAC. So if I just simply query this through, what happens now is that in the engine, let me go back here, you will see that we have a rule that basically looks like this. So let's go here, we say that if the data is above the threshold, and if it's not a weekend, send an email to the person, which is basically the input argument that came through this application. And now what I'm going to do is that I will just shift hit this thing here, and let's see what happens. So let me go back to the rule, and I'm just going to push now 10,010 compressing hours, and you see basically that the rule has triggered at the runtime, so we can go back and see here. So we have sent an email on this resource because it went above 10,000 compressing hours. And by the way, while let me just show you here, that you see that email has triggered, and you see here HVAC with this ID has actually crossed the threshold and got an email. If you look closely into the rule, if you like, then you will see how easy it is to build user interface, because basically what you're doing is that you have a JSON expression of the rule with a set of sensor actuations, their relations, and this application here that you saw before, it's nothing but a small mock-up UI on top of the JSON interface, so to speak. The next benefit of having the good explainability in the tool is that you can as well tell a story while looking at the use case itself. So what I want to say here is that you really don't have to be an expert in automation or a developer to understand what's going on here. And this is one of the reasons why finite state machines are very easy to be understandable by people, because for the state transition and states, they can actually see how things evolve and kind of follow. I have to say that our news engine is not finite state machine, it's something else, but again, I'm just giving you here opinion that looking for the states is always easy to understand what's going on here. So for instance, here we have a temperature which has to go above the threshold to find the asset, and then if you find that one, then we're going to create a ticket. Similarly, if the value is above the threshold, and we also find a support person, now we have both found the asset on a given location, we find the person who is managing that HVAC on that location, and that person is going to get an email and emergency call. Again, so what we'd like to do now is just try to debug that in a very easy way. So let me go back now here, and let's open that use case. So let's have a fun. So I'm just gonna start it again in debug mode, this rule. And what I'm gonna do now, I'm just gonna push a temperature that go above a particular threshold. Let's see whether I've been kicked out of the, okay, so just hold on a second. Let me start it again. Okay, so here we are above the threshold. We find that the asset was found. The Zendesk is going to be created, and you want the address, Waylay, letter 633. Yeah, get. And temperature is 20. Hopefully you have heard that. So that was the voice call that I received about the asset problem on a given location. And let me just now show you another thing that you see here. I've got an email that temperature was 21 degrees. And that asset was found at this location, so this is where our offices are. And then again, we can easily, again, the point I want to make here, debug the use cases, and again, either developers or business owners have an easy understanding of what they all actually would like to achieve with this rule. The next thing that I wanted to point out here is that, again, what is important is to be able to, like what I'm doing now, simulate that stuff before deploying in production. And then it's also interesting if you can actually, afterwards when stuff is deployed, at the runtime check the stuff is still working properly. So what I'm going to do now is I'm going to start that template for a given HVAC. So let me just delete one from before. I'll just stop it here so we don't have too many things running. I will select this template, so about assets, and I will deploy that, for instance, for the HVAC one. So let's just do that. And I'm gonna copy that. And you see now that I have deployed that rule for the HVAC one. And now I will, at the runtime, start pushing the data towards the system. And Let me just log out and be able to log in again. All right. So let's see and push the data. And what you see here now at runtime again. So this is now system running, and make no mistake, I'm getting the second call that there is issue with another HI. So what you see here is that now the rule has been deployed, and you can still do debugging the same way and at the runtime check what's going on like you were doing at the design time. So which is really, really very important. What often happens is that people ask themselves why this rule has triggered, and then just looking at the logs sometimes it's not as trivial. Specifically, there are if the rules or the data that triggers the rules are very complicated. Then the next thing that we also see customers doing is that they can as well test the rules against the data logs. So for instance, if you are a company that manufactures fridges or ovens, you often get the data logs and then you wonder what's wrong with it. You would like to do multivariate analysis, or you would like to check the error codes. You would like to deploy these rules, but again, you have already some data that you have captured from the field. So what you can actually do with our system is that you can go back to for instance, the one that I was just showing here. Let's say, let's call this now HI2. And now I can take data from the field, and I'll push that and see if my rules will trigger, providing I have these data logs in my system. So for instance, what you see here now is that I have pushed the temperature 30 degrees, and you see that rule has triggered, and you can actually see it here. If I look at that particular entry point in my logs, obviously that rule does not require humidity and CO2, it just requires a temperature. But again, if I look at here, I can actually see that my rule has triggered, and that incident has been triggered by the stream sensor, which was above the threshold. Again, if I just enable this actuation, that would mean that I can as well test whether I should get an SMS or email, and then again, make no mistake, I'm getting now the call that the asset HVAC2 was in the temperature alerting state. So this is again another thing that you would like to do. It's that capability to use the logs that come from different machines, create rules, and then basically use the same rules against the logs as well against the real-time data. The next category of the capabilities that we would like to have in automation is what we call adaptability. And here we talk about two different things. One is about having a flexible environment. What we mean by that is that often you apply a rule, for instance, for a given water meter in utility, and after a while you have to actually add some additional tasks, some additional rules, or you have to change the existing ones. People change their ideas, opinions, or because of the regulations, you have to do some other things and change the rules. And you would like to do that without any disruption. Similarly, you would like to extend rules with some other capabilities to change them, but also should not forget that often the rules depend on the API endpoints, and this is as well are often moving targets. It might be that SMS provider has become very expensive, you'd like to change it to the other one. Or what often happens is that API gets deprecated, you have to change it with the next API endpoints. And again, the last thing you would like to do is to have disruption of your automations. And again, I will just show you here one example that I found in literature. Luckily, it does not happen in Europe because we cannot have a carbofuran, which is pesticide, which is often was in use in the past, which can get traces in the water. And what then happens is that you need to change the conditions under which you're testing the quality of your water. So the story starts with testing only for one particular metric, let's say benzene. But then what the new findings say is that because there are not one but two possibly toxic materials, you have to change the way you are testing your water tanks and so forth. So what I'm going to do now is to explain how this can happen in practice is that I will take, for instance, a template, let's say, that checks that benzene is below 10. Okay. So what I'm gonna do now, I'm just gonna create a water tank template, or other loop, which is based on this. So let me just run that for, let's say, water tank 1. I will need it later on to remember that. So here you see now I have deployed a rule, and then if the, let's say, what I'm doing here, we are having the water tank, and we have a benzene, and let's put it to 5. And pushing data, we are below the thresholds, and if we are doing that, let's say 15, there we go. We see that we are above the threshold, so we have alarm. And suddenly what needs to happen is that we have to basically create a rule that looks a little bit different. Let me just show it here. What we need to do now is to, for the same water meter, or water tank rather, we have to create a rule that water is of a bad quality if either the benzene is above 10, or if this one, or the benzene is above 5, as well the carbophone is above 5. So what we have to do now suddenly is to basically change the rule for the existing water tank without any disruption. So what I'm going to do now is that I'm going to do exactly that. So what I'm going to do now is I will take this template and save it for the running rules. And what I will be now doing is that we have already water tank. Let me show it here. That it's on the rule that looks like that. And now we're going to change that to a rule that takes into account additional magic. So if I now refresh this task, you will see a magic. Wow, now suddenly we have changed the rule on the fly. And now if I push the data for the carbofuran and benzene. All right, let's take this 6 and let's push it here. You'll see now that we are getting the alarms both because we went above 10 here, but also these other two have been triggered as well. So this is one way to look at the capability of the adaptability in the context of the flexibility to be able to change the logic. Often I call this sort of capability changing the wheels while driving the car. And again, this is in the slides, just support of the things that I've just done now, by being able to change the logic of a rule for existing instances. Another example, it's something else that we often do. It's that you often see the IT people being very scared, if you like, of putting automation in practice because they have the SAPs in Salesforce, they have all sort of security concerns. So what you would often do is that you, in the POC, use one ERP system or notification system, and suddenly you would like to replace it with the other one in production without, again, zero downtime. So what I'm showing you here, it's exactly the same rule, where, for instance, this has been implemented using the SAP, while that one on the right-hand side has been implemented by the Salesforce. Because in our system, we can replace pieces of information that we call a sensor framer. It's really easy to replace one dot with the other one. And again, in this case, you will not get a Zendesk ticket, but you will get a case in Salesforce and stuff like that. But again, this is one of the things that you would really like to have. Specifically, if you would like to play with a sort of a template story of the utilities, where the actual customers can have a different sort of a backends. And that's, again, like I said, often happening in the big enterprises. Then you also saw me doing something with the template. So this is the next part of scalability, which is, if you like, nothing to do with how many things you can do per second. But the scalability often means also in operations how you can deal with the possibility to do the bulk upgrades on 1 million devices. having the right versioning, having the means to search through your templates and so forth, and rules analytics. Again, here I'm just listing things that you've seen me doing before. It's a capability to create the templates, and then also what you see here is capability to have the version of the sensor actuations, and you see the differences of that, and being able to update rules for the different versions of the sensor actuations, and then as well being able to search by looking how many of the rules are using the API for a weather forecast, how many APIs are using notifications from the SMS, trillions, that sort of thing. And finally, but often it's the first thing that people mean when we talk about scalability, is actually, if you like, a brute force scalability in context of how many things you can do. And that often boils down to capability of your tool or framework to do linear sharding. What I mean by that is if you have n times the same component, you should be able to do n times the same thing. And again, these are the things that some rules engine and some embedded frameworks are better than others. But again, what I mean by that in the context of what we offer, it's a capability to do the sharding of the rules engine evaluation, being able to do the complexity and processing on the fast streams in memory, being able to shard and delegate executions. You have probably heard about serverless patterns or cloud functions. This is one of the examples of these sort of things. And then eventually things that are related to the normal detection and prediction, they have to be sharded. Finally, like I said, there are a couple of white papers that we have written about the rules engine, benchmarks, and frameworks. We have come up with our own set of categories of rules engines based on their capabilities, based on the family of algorithms that implement rules engine capability. And again, we talked about forward chaining, flow-based processing, condition action, rules engines, decision tables, finite state machines, complex stream processing, and stream processing engines. And here on this slide, you can see some of these, as you probably can recognize some of these. Then you will also find in the white paper how we benchmarked. Now you know a little bit more about the metrics. Again, coming back to the story of the apples, comparing apples to apples, we made an effort to somehow define these metrics to be able to measure capabilities of different rules engines. And here you can see the results. Now, one thing that it's also a fair point is that often people ask, so how much of this sophistication I need for exactly my use case? So what we also tried is to look at different verticals and see which of the rules engine capabilities and automation capabilities are required for a particular vertical. Some, if you like, verticals are more picky than others. For instance, if you're in a smart home environment or agriculture, you have to deal with uncertainties, you have to deal with explainability, obviously, while some others are, let's say, more easy. You know, if you like, talk about geofencing, you're in or out, and you have to send SMS or email, well, then you might just leave this at that sort of application. But again, this is effort that we try to make to show you that as well. So, and then if you combine all of these things together, it's like for which vertical I need which sort of the rules engine, you end up with this sort of table. It also explains, if you like, while majority of the IoT platforms have more than one rules engine of a different kind. Because exactly the point I want to try to make earlier on is that not every rules engine that we know the market is good in expressing some of the things I was talking about today. So with this, I would close the today's webinar, if you like, on what I wanted to say today. Again, there are two very detailed white papers. We talk more in detail about some of these things. So I will now just maybe stop for a moment and see if there are some interesting questions from the audience. Thank you.
Yeah, thank you everyone for your time and for your attention. Most of the questions that we've received in the registration forms and also here are regarding whether or not we're going to be sharing the slides with you. And so I'd like to confirm, yes, we will be sharing the slide deck with you, and also we will be sharing the recording, the video recording of this webinar. Other than that, I see just one question here. Do you see it, President?
Yeah.
I see two questions here. Okay, so as part of the operations, how will this platform help with updating IoT devices?
Yeah, that's a good question. So I'll give a real examples of what people actually doing. You can think of the automation context on the real use case of the rules engine, but you can also think of that in context of the firmware upgrades. I did discuss one particular feature which we have, which is called discovery template, which enables operator to run a specific rules on a given meta model. And I mentioned earlier on that in our rules engine we can also access the meta model of device. So what I know customers doing is that for a particular firmware they need to do some provisioning tasks. And then they can use the template which they prepare once, and then they hit their own API endpoint for a provisioning. You didn't see me doing today, but again, trust me, this it takes about 5 or 10 seconds to create your own application with your own API endpoint, and then you can actually create provisioning scenarios the same way as you would do some other asset tracking scenarios.
Okay, there's another one I see here. Is it possible to create these rules on this representation but execute them on a local device?
This is an interesting thing that I'm talking about 5 years ago when we created this rules engine. There are no technical reasons why this cannot run on a device. But again, we are the cloud company, and we have decided for the moment to expose this rules engine over the cloud or over the private deployments, meaning that we have customers which are, if you like, deploying our automation technologies, they call today a thick edge. Meaning you have the Kubernetes cluster where rules engine is part of that. Having said that, in 2016 already, we had our rules engine in collaboration together with Cisco in the routers, just as a proof of concept that this sort of automation technology can run on a device itself. Having said that, you're probably better off running this sort of the rules engine in gateway rather than on a device which is constrained. Again, the point I want to make here is that even though it's technically feasible to do these things, we do not offer that off the shelf as a capability to the end users.
Okay, that's going to be it. Thank you very much, everyone, again for your attention, your time, and your interest. We will be following up with new webinars very soon, so we will be in touch about that. Thank you again. If there are other questions, you can get in touch with us directly at veslen@waylay.io or visit our website www.waylay.io. Thank you very much. Have a great day, everyone.
Thank you.